All right, so let's continue our lesson. So we are continuing from where we ended in lesson 2. So today's lesson in lesson 3, we are going to look at the properties of operations of set of numbers. We've already talked about this various set of numbers. We've talked about um, real number system. We looked at natural numbers, whole numbers, integers. We also looked at rational and irrational. So today we're going to deal with properties of operations. And when we talk of operations, what are the basic operations in mathematics? We can think of addition, multiplication, subtraction, and division. So these are the basic operations in mathematics. We have other operations. We can use symbols to represent what? Other operations. So if you talk of binary operations, there are other symbols that can be used to represent operations. All right. So we'll not waste time. Let's list these properties of the operation of set of numbers in the senior high school mathematics. So one we can think of or talk about um, commutative, commutative property, commutative property. We can also talk about associative property. Another one is distributive, distributive, distributive property. We also have identity. Another one is inverse. And we can talk also about closure, closure property. Good. So all these are properties of operations of set of numbers that we shall be looking at in this lesson. So we are going to take them one after the other. We look at examples and then we see what to do. All right. So let's first consider commutative property. Commutative property. Commutative. Okay. So for commutativity, we are saying that if we have an operation which is defined under what a set, if we operate two elements, or if we combine two elements in the set using the given operation, if the answer we get at the right side or at the left side is the same as the answer we get at the right side, when we change their positions, then we say that operation is commutative. Okay, so for commutativity, we can say that if an operation, so let's say if we have this operation, let's say we have this operation, if this operation is defined on a given set, so let's say this operation is defined on a set, so let's say we have set S. Okay, if we have set S which is equal to, so these are set A, so we have A, B, and C. Now these are the elements we have in set what S. So if we have this operation defined on this set which is set S, Okay, if we take any two elements, so let's say we are taking A and B. If we should take A and combine using this operation, so if this A operates with the B, this should also be the same as when B operates with what? A. So since A operation B is equal to B operation A, if we have this, then we can say that this operation is what? Commutative. Okay, so commutative, there's commutativity if and only if. So if and only if A operation B is equal to what? B operation A. Okay, yes. So this is what the definition for what? Commutativity. Okay, provided A, B are all members of what set S. Have you gotten that? So what we are saying is if we find or if we take two elements and operate with each other, if we change their position, the answer we get, if the answer are the same and can also be found in the set, then we say that that operation is what? Commutative. Okay, have you gotten that? Good. So let's say we have this. So let's take let's say set of um natural numbers. So we are given set of natural numbers. So let's say we have 1, 2, 3, 4 to infinity. So these are set of natural numbers. Now let's say we are going to use addition as the operation. So I'm going to pick two elements from set of natural numbers. So I'm taking 1 and 2. If I write 1 plus 2, which is equal to, so this time 1 comes first and then 2 comes last. So when I go to the right side, what I will do is I will only bring 2 first and then bring 1 last. So when you go to the left side, 1 is first and 2 is last. But when it comes to the right side, 2 is first and 1 is what? Last. So after operating or combining these two elements, so 1 plus 2 gives me what? 3. Is it the same as 2 plus 1? Yes, 3. So once we know that what we got at the left side is the same as what is at the right side, then we can conclude that addition is what? Commutative. Addition is what? Commutative. So we say addition of natural numbers. Addition of natural numbers is what? Commutative. So that is what we mean by what? Commutativity. Okay. Now let's take another one. So let's use multiplication. Let's use multiplication. So I'm picking these same element, or let me pick two different elements. So this time I'm going to pick 2 and 4 and use multiplication. So if I have 2 times 4, which is equal to, so this time I'll write 4 times 2. Now let's see, if we multiply this, we are getting what? So 2 times 4 will give me what? 8. Well, 4 times 2 also give me 8, yes. So since here is 8 and here is also 8, we can then conclude that multiplication of natural numbers is what? Commutative. So that is what we mean by a commutative property. So there's commutativity if and only if these two numbers, after changing their position, each will get what? The same and numbers or the same answer. So that is what? Commutativity. Now let's try addition. We have already tried addition. We have also tried what? Multiplication, and it worked for us. So addition and multiplication, both of them are what? Commutative. Okay. Now let's try subtraction and division. So I'm going to pick another two numbers from here. So this time I will pick 2 and 3. So 2 minus 3 is equal to 3 minus 2. So we are going to prove or show whether this is true. This statement is true. Okay. Now 2 minus 3 gives me what? Negative 1, which is equal to 3 minus 2 gives me what? Positive 1. Are they the same? Since this is negative, this is positive, we can't say they are the same. Therefore, this is not the same. If they are not the same, then we can conclude that subtraction is what? Commutative. Okay. So subtraction of natural numbers is not what? Commutative. All right. Okay. Now let's also use division. Let's use division. So this time too, I'm going to pick another two numbers. So I'm going to pick 1 and 4. So 1 divided by 4 is equal to 4. So this is division. Is equal to 4 divided by 1. Now let's see. 1 divided by 4 gives me what? So we have this as 1/4 or 0.25. We still get 0.25. So let me write 0.25, which is, so 4 divided by 1 will give me 4. 4 here. So are they the same? They are not the same. They are not the same. Since they are not the same, then we can also conclude that division of natural numbers is not what? Commutative. All right. So we can conclude that addition, 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 and multiplication are commutative. Whereas, or while, or but, they are commutative, but subtraction, subtraction, and division are not commutative. Good. So if we know that when we have this, then we can conclude that subtraction and division are commutative, while we can conclude that addition and multiplication are commutative. So this is what the commutative property or commutativity. Okay. All right. If that is the case, then let's look at the second property, which is what? Associative property. So we have the second property, which is what? Associative property. Property. Great. So for associative property, what we are also saying is if we have this operation which is defined on this set S again, so I'm using set X with the element A, B, and C as the set of what? S. So set S has this element, and this is operation. This operation is defined by this. So for associativity, what we are saying is if I pick three elements from the set and operate, and operate with the given operation, if the answer I will get at the left side is also the same as the right side, then it is what? Associative. That property is associative. So for the definition of associativity, we are saying that if I should take this element A operation, then I have my B operation, what? C should be equal to A operation B operation C, and should also be equal to, if I have A operation C operation B. So if this is true, if this statement is true, then we can say that, or we can conclude that this operation is associative. All right. So let's pick example, or let's use numbers. Um, so let's use numbers. So let's say we have set of real numbers. Set of real numbers. Okay, we know that real numbers constitute, or real numbers comprise. It comprises both rational and irrational numbers. We have already treated rational and irrational in our previous lesson. So when we ask you to give examples of real numbers, you should be able to give. So let's say we are going to pick three real numbers. So let me see. I'm using so set of real numbers. I can have example. Let's say I have 2, 3, 4. Set of real numbers comprise a lot of numbers. So I'm just using only 2, 3, and 4. All right, great. So if I have these three numbers represent the A, B, and the C. All right. So and then I'm going to use our four basic operations, which are addition, subtraction, multiplication, and division. So let's use addition first. So if I pick this 2 plus, then I have 3 plus 4. The associativity property states that if I have this should be equal to 2 plus 3 plus 4. At the same time, should also be equal to 2 plus 4 plus 3. So let's work out and see if they are the same. So we shall always deal with what is in the bracket first. So 3 plus 4 gives me what? 7, which is equal to 2 plus 3 gives me what? 5 plus 4, which is equal to 2 plus this gives me what? 6 plus 3. So let's add them. So 2 plus 7 gives me what? 9. Okay. And 5 plus 4 gives me what? 9. All right. And I have 6 plus 3 gives me what? 9 as well. So since this is true, because if we add this, we are getting 9. Here is also 9. Here is also 9. If this is true, then we can conclude that this property, which is addition is what? Associative. Okay, addition is associative. All right, now let's use multiplication and see if that one will also work. So let me continue from here. So I'm going to use the same numbers. So if I have here 2 times 3 times 4, it should be the same as 2 times 3 times 4. All right, it should also be the same as 2 times 4 times 3. All right, great. So let's work out and see. We are going to test whether multiplication will also be associativity. So always we deal with what is in the bracket first. So 3 times 4 gives me what? 12, which is equal to 2 times 3 gives me what? 6. Okay, times 4, which is also equal to 2 times 4 gives me what? 8 times 3. Now let's multiply this. So 2 times 12 give me what? 24, which is equal to 6 times 4 also gives me 24, which is equal to 8 times 3 also gives me what? 24. Great. Now, is this true? Yes, it is true. 24, 24, 24. So since this is true, we can also say that multiplication of real numbers is what? Associative. Okay, it's also associative. So addition and multiplication, both of them are what? Associative. Let's try addition and let's try subtraction and what? Division, and see if they are also true. So we are still using the same numbers. So I have my 2 here minus 3 minus 4, which is equal to, I have 2 minus 3 minus 4, which is equal to 2 minus 4 minus 3. So let's work them out and see. So always we do what is in the bracket first. So I have 2 and then minus. So 3 minus 4 will give me what? 1, negative 1, which is equal to, let's do what is in the bracket. So 2 minus 3 also gives me negative 1, negative 1 minus 4, which is equal to 2 minus 4 gives me what? Negative 2 minus 3. Now let's work them out. So 2 minus negative 1. Since this is negative, this is this is minus, this is negative. So negative will be positive. So it means here will be plus 2 plus 1 gives me what? 3, which is equal to negative 1 minus 4 gives me what? Negative 5, which is equal to negative 2 minus negative 3 gives me what? Negative 5. Great. So let's compare whether they are the same. Now you see that here is negative 5, here is negative 5. Someone may say that, but here is they are the same. But ask yourself, this one is 3. Are they the same? No. So since these, all of them, because all of them must be the same. Looking at the addition and the multiplication, we've got 24, 24, 24, all the same. But if you come here, here is 3, here is negative 5, negative 5. They are not the same. Because they are not the same, we can also say that subtraction is not associative. All right? Subtraction is not also what? Associative. Now let's try division as well. We are using the same numbers. So we have 2 divided by 3 divided by what? 4, which is equal to 2 divided by 3 divided by 4, also equal to 2 divided by 4 divided by 3. Now this one, the first one, when we dealt with subtraction, because they were not the same, you should be able to bring this. So this shows that they are not the same. All right, great. So let's deal with the division. Always we do what is in the bracket first. So we have 2 divided by, so 3 divided by 4 is what? 3/4, which should also be equal to 2/3 divided by 4, which is equal to half divided by 3. All right. So if we are doing this, if we divide 2 by 3/4, then we are going to get 8 on 3 is equal to, if we divide this by this, then we are going to get 1 on, so here will be 1 on 6, all right, which is equal to, if we divide this by this, then here too we are getting 1 on 6. All right, so let's compare answers whether all them are the same. So this one too, we can see that here is 8 on 3, 1 on 6, 1 on 6, even though these two are the same, but it's not equal to this. Because of that, we can conclude that they are the same. So our final conclusion is going to be this division is not what? Associative. Division is not associative. So for associativity, we can also conclude that addition and multiplication are associative, while subtraction and division are not also what? Associative. All right, great. Great. So if we are able to identify all these examples, then we just conclude that that one is not also what? Associative. All right. Okay. Let's move on to our next property. So we are also looking at distributive property. All right. So is our third property, which is what? Distributive property. So distributive property. So for distributive property, now when it comes to distributive property, you see for commutativity and associativity, uh, we used only one operation. But when it comes to distributive property, we're going to use two different what operations. So let's say if we have this operation, we have operation star and this operation delta. If I have these two operations which operates, so if these two operations are defined on the set of S, set S, then I can. So we have A, B, and C. All right, great. So if I have these two operations, what this distributive property, what this is saying is, um, whether one of the operations, any of the operation is distributive over the other. So it's either star is distributive over delta, or delta is distributive over what? Star. So for this one, we are saying that star can be a distributive over delta if and only if we have, let's say, if I pick any this element, so star, if I have star and then B, so if I pick any three elements, so this and then operation C, then this should also give me A star, A star, B delta, or operation this A star C. You get that? So this one is just a mere what? Expanding of bracket. When you are expanding bracket, if you remember your algebraic expression in the junior high school, how we expand bracket, that is how this distributive property what it behaves. All right, great. So it's just a matter of this operate with this, then this operates with what? This. For instance, if I should give you, let's say, um 2 2 times, let me bring my times here, multiplication sign here, and then we have maybe x plus 1. Yes, so if we have this, you see that this is multiplication, this is addition. We have two what operations. So when it is multiplication, we only what expand the bracket, so we open it, so it is 2 times what x, and at the same time 2 times y. So that is how this distributive property behaves. All right, so we only have to multiply this by this, so 2 times x gives me what 2 times x, all right, plus 2 times 1. So that is how it is, so that we get what? 2x plus 2. Have you seen that? That is how this distributive property behaves. So probably we need to get two operations. All right, great. So if you have two operations, then it will work for you. So that is what this property is saying. So looking at this, you could see that this operation star is distributive over this delta only if this is equal to this. All right, good. So let's pick a set of real numbers. So let's say we have set of real numbers. So I'm going to there are a lot of examples of real numbers. So let me use, let's say we have 1, 2, 3, 4. So I'm using only this uh, counting numbers as what part of row set of row numbers. I'm only using this. All right, great. So we are going to pick three numbers and use multiplication and addition or subtraction. All right. So if I write 1 here times 2 plus 3. So you see here I'm using two operations. I'm using multiplication and what? Addition. All right, great. So let's open the bracket because that is what that property is saying. So the one will operate with 2 and at the same time one will operate with what? 3. So I can have 1 times 2 plus 1 times 3. All right. So what this property is saying that if I work out this, the answer I get, if I work the other side also too, if I get the same answer, then we can conclude that this multiplication sign is distributive over what? The addition. The distribution, or the operation that comes first. Which operation comes first? This is what? Multiplication. So always we deal with what is in the bracket first. So I'll write my 1 times, so 2 plus 3 gives me what? 5. And then let me also work at the right hand side. So 1 times 2 gives me 2 plus 1 times 3 gives me what? 3. Now let's see. So 1 times 5 gives me what? 5. And then 2 plus 3 gives me what? 5. So are they the same? So you see that the left hand side is the same as the right hand side. Since they are the same, then we can conclude that this multiplication sign. So multiplication is distributive over addition. All right, that's how you conclude it. Now, don't say because this time it is multiplication first, so you are going to change it and bring what? The addition also first, because if I should bring addition first, how does it work? We can't expand what? The bracket. For instance, if I write it this way, 1 plus 2 times 3, I can't expand the bracket in such a way that this 1 is going to add this in this 1 plus 2 times 1 plus 3. It doesn't work like that because there's no way you are going to tell me that this plus this as we did in the multiplication. No. So this one is totally wrong. Have you gotten that? Addition. So this concludes that addition cannot be distributive over what? Multiplication. So always for distributive property, if when it comes to the four basic operations, it is only what? Multiplication, which is distributive over either addition or subtraction. Because if I should change this as what? Subtraction, definitely I'm going to get that. So let me try this example. So let's say I'm using the subtraction. 1 times 2 minus 3 should be equal to 1 times 2 minus 1 times 3. As for addition and subtraction, we can do that. So let's do what is in the bracket first. So we are tackling the left hand side. 2 minus 3 gives me what? Negative 1, which is equal to 1 times 2 is 2 minus 1 times 3 is 3. So let's multiply this. 1 times negative 1 will give me negative 1, which is equal to 2 minus negative 3, and 2 minus 3 will give me what? Negative 1. So you see that negative 1 is the same as negative 1 here. Because of that, we can also say that multiplication is distributive over subtraction. So take note. All right. So multiplication is distributive over subtraction. So for distributive property, when it comes to the four basic operation, it's only what multiplication, which is distributive, over addition and subtraction. The rest we cannot get that. The rest cannot work. We can't say addition is distributive over multiplication. We cannot also say division is distributive over multiplication. So it deals only with multiplication being distributive over addition and subtraction. So take note of this. So that is the distributive property. All right, great. Now let's also look at our property 4, the property 4, which is what? Identity property. Identity. Great. Identity property. So let's talk about this. So when we say identity, what is an identity? So for this identity, we are saying that this is a number. Identity, this is a number. This is a number. When operates with another number, results that same number. Good. So that is what identity. So we are saying that for identity property, it is a number. When it operates with another number, the result will be that same number. That is what we mean by that number will never change. Have you gotten that? Good. So that is identity. But before we look at those numbers, let's talk about the two main types of what? Identity. Two main types of identity. So we have types of identity. All right. So for the types of identity, we have one being what? Additive identity. Additive identity. So for additive identity, what we mean is this is a number that because we are dealing with addition, so when you add that number to any real number, the result or the answer you get will be the same that real number. Have you gotten it? So you ask yourself, okay, then what number are we talking about, or what number are we looking at? A number, when you add to another number, you will get that same number. That number will not change. For addition part, that is the additive identity. So think of a number. Which number should I add to another number? And the result will give me that same number. So for additive number, we say that what? The additive number is 0. When you add 0 to any number at all, you will still get that what? Number. So let me give you an example. So if I add 0 to 5, I'm getting 5. 0 plus 3, I'm getting 3. 0 plus half, I'm getting half. So whenever you add 0 to any number at all, you still get that same number. That is what we are talking about. That is the identity we are talking about. When you operate, and what is the operation? The operation is what? Addition. That is why we are saying additive identity. So additive identity is what? 0. When you add 0 to any number at all, you still get that number. And the second type, or the last type of identity, is what? Multiplicative identity. Multiplicative identity. So what is multiplicative identity? So for multiplicative identity, we are saying that this is also a number when you multiply, eh, when you multiply this number by any number at all, you still get what? That same number. So looking at the difference for additive identity, if you add that number to another number, you get the same number. For multiplicative identity, if you multiply that number by another number, you get that same number. So that is the difference. All right. So which number, you ask yourself, which number that if you multiply by another number, you still get another number. So for multiplicative identity, it is what? 1. 1. 1. Okay. So multiplicative identity is what? 1. If you multiply 1 by any number, you are still going to get what? That same number. So 1 times 3, you still get 3. 1 times 2, you still get 2. 1 times 3 fifth, you still get what? 3 fifth. Have you gotten that? So it means that when you multiply 1 by any number at all, you still get that same number. That is what we are talking about, what? Multiplicative what? Identity. All right. So if I ask you to give me or write the additive identity and multiplicative identity, you should be able to tell me that the additive identity is 0, while multiplicative identity is also what? 1. So that is what we are talking about. All right. Great. Now if that is the case, then let's look at the next property, which is property 5. So we are also talking about the next property. So property 5, we are talking about inverse. 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 All right. Great. So when we talk of inverse, what do we mean by inverse? Inverse property. So for inverse property, we are saying that it is also a number when operates on another number, that produce what? The identity. Okay, we have already talked about the identity. We are saying that when this is a number, so this is a number, this is a number operates when operates with another number results the identity. Good. So that is inverse. So the inverse is also a number. When you operate with another number, the answer you get will be the identity number. That is what you are talking about. Okay. So for this one too, we also have two types of inverse. So we have the additive inverse, additive inverse, additive inverse. That is the first one. So for additive inverse, what we are saying is this is a number. If you add to any number, you will get the additive what? Identity. So you ask yourself, if I pick a number, which number should I add to get what? 0, because we are saying that the additive identity is 0. So if the additive identity is 0, then we are also talking about additive what? Inverse. And we are saying additive inverse is a number when you add to a number, then you should get the additive what? Identity. So probably for additive inverse, it is the opposite. It is the opposite of a number. So for example, if I give you example 3, so let's say this is 3. What should I add to 3 to get the identity? To get the identity element, what should I add? So it is the opposite. So I should add negative 3. So if I add negative 3 to 3, what am I getting? I'm going to get 0. And 0 is the identity what? Element, or the identity number. Okay, good. So in conclusion, we can say that the inverse of this 3 is negative 3. Have you gotten that? The inverse of this 3 is negative 3. That is what we are talking about. Okay, so for instance, if I should say that if I operate, so most of the time we use the I, we use the capital I to represent what? The inverse. Okay, we use capital I to represent the inverse. All right, great. So that is what we are talking about. That is what we are talking about. Now, if I give you this, negative 5, okay, negative 5. What should I add to negative 5 to get the identity number? So if I add 5 to it, I'm getting 0. Have you gotten that? So if I ask you to find the identity or the inverse, if I ask you to find the inverse of this 5, the inverse of negative 5 is what? 5. Because if I add 5 to the negative 5, I'm going to get 0. So that is what it means. If I write this, half, this is the number I have. How do I get the identity number? I have to add negative half, all right, which will give me 0. So this negative half is the inverse or the additive inverse of this half. Okay, this 5 is the additive inverse of negative 5. This negative 3 is the additive inverse of 3. Have you gotten that? Great. So that is the additive inverse. Now let's look at the second type, which is what? Multiplication. Multiplication or multiplicative inverse. Multiplicative inverse. Inverse. Great. So for multiplicative inverse, this one also, we are saying that if I should multiply, if I have a number, which number should I multiply to get the multiplicative identity? We all know that the multiplicative identity is 1. Multiplicative identity is 1. So if I give you a number, you ask yourself, what number should I multiply to get the multiplicative identity? Have you gotten that? Great. So if I give you this, now before we do that, know this. So if I give you, for the additive inverse, if I give you A, know that 8 additive inverse is what? Negative A. If I give you negative B, 8 additive inverse is what? B. Okay, so when it is positive, 8 inverse becomes negative. When it is negative, 8 inverse becomes what? Positive. So that's what you are talking about. All right, great. Now for multiplicative inverse, if I give you this, let's say A, all right, what will be the inverse of this, the multiplicative inverse? It means that what should I multiply by A to get 1? 1 is the multiplicative identity. All right. So this A, 8 multiplicative inverse is what? 1 on A. Because if I should multiply this, by this, am I not getting 1? Have you gotten that? So this one, this is the inverse. So the inverse, the multiplicative inverse of A is what? 1 on A. 1 on A can also be written in this form: A exponent negative 1. This is an inverse form. Okay, so this is an inverse form. Now if I give you B, let's say you have B, what will be the multiplicative inverse of B? Multiplicative inverse of B is going to be 1 on B. If I multiply, I'm going to get what? 1. Because at the end of the day, this one will cross this and then leaving 1 behind. Have you gotten that? So for additive inverse, what number should I add to the number to get the additive identity, which is 0? For multiplicative inverse, what number should I multiply to get the additive and the multiplicative identity, which is 1? That is what we are talking about. Have you gotten that? So, for instance, if I give you this, so let's say example, if I give you this 5, what will be the inverse of 5? So the inverse of 5 is going to be what? 1 on 5, or 5 exponent 1. This is the inverse, because if I should multiply this 5 will cross this, leaving what? Which is equal to 1. So the 1 is the multiplicative identity. I've gotten my 1. Have you gotten that? So that is what we are talking about. All right. If I give you this negative 3, how do I get 1? If I give you negative 1, so what should I multiply to get 1? So I can multiply this by what? Negative 3, so that this one will give me the 1. So it means that the multiplicative inverse of negative 3 is negative 1/3, which negative 1/3 can also be written as this: negative 3 exponents this, and it will give you what? 1. So when we ask you to find the multiplicative inverse of a number, what you need to do is you ask yourself, okay, what number should I multiply by that given number to get 1, which is what? The multiplicative identity. All right, that is what we mean by that. Okay, so it's very, very, very simple. All right, so that is all about the inverse property. Now let's end our lesson by talking about the last property, which is what? The sixth property, which is closure closure property. Closure property. Closure property. Good. So for closure property, what we are saying is, if I give you this operation and I give you another set S, all right? So we have set S, which is A, B, C, all right? So for closure property, what it says is, if this operation is defined on this set S, if I pick two numbers, okay, if I pick two numbers and operate with each other, then the answer I get must be found in the set which is given. Have you gotten that? So what we are saying is, if I pick A operation B, this should be what? This should belong to what? Set S. That's what we are talking about. So if I pick two elements and operate with each other, the answer I will get should belong to what? The set S. That's closure property. So for instance, if I have, let's say, set M is equal to 1, 2, 3, 4. So if I have this, now I'm going to use addition as the operation. If I pick two numbers from here, all right, so let's say or let me add this. Let me add this. So let's say this continues. So set M is what? Set M, we say that it can be what? Natural numbers to the infinitive starting from 1. Okay, so let's say I have this. If I pick two elements, which is 1 plus 2, this is the operation. If I operate, I'm getting 3. So you ask yourself, is the 3 also a member of set M? If this 3 is a member of set M, then you can conclude that this addition is closed under this set. Okay, this is the operation. The operation is the addition. It is closed. All right. Now, if I write 3 times 2, what answer will I get? 6. So you ask yourself, is 6 also a member of set M? Yes, 6 is there because we brought this, meaning that there are more numbers. Definitely 6 is also there. So since 6 is also a member of the set, then you can also conclude that this operation, which is multiplication, is closed under what? Set M. Have you gotten that? Now let me use subtraction. If I do this, let's see. If I write 3 minus 1, okay, 3 minus 1, what answer will I get? 2. Now let's look at something very important. This is 2. Now you see that 2 belongs here. Okay, 2 is in the set. Because of that, we can say that the subtraction is also closed. But let's do this other way. What if I write this 1 minus 3? What will I get? I will get negative 2. If I change their positions, will I get the same? No, I won't get the same. So normally we say that subtraction is not closed under what? Natural numbers, because it is not always. It is not always. When we subtracted 1 from 3, we got it. But when we subtracted 3 from 1, we got an answer which does not belong to natural what? Numbers. Have you gotten that? So that is what we are talking about. Okay, good. But if you come to addition, if you change, even if you change the position, so 2 plus 1, you still get 3. If you change here their position, you still get the same. So for addition and multiplication, always they are what? Close. But when it comes to subtraction and division, it is not always. Okay, it is not always, right? Great. Now let's say we talk of real numbers. Now when we talk of real numbers, we know that real numbers deals with both rational and irrational. Okay, so if you want to know whether addition is closed under real number, you pick two numbers and then you change their positions and see if they will all work. If they all work and you see that they are all found in that set, then you can say the addition is closed. You do the same with multiplication. If you get the answer, if you change their positions and you see that all the answers are also found in set of real numbers, then you get the answer. All right. So all that we are saying about closure property is whenever you are given a set and you are given an operation which is defined under that set, you just pick two or more elements and work with that operation. If the answer you get can be found in that set given, then you can conclude that that operation is what? Closed under that set. So that is all about what? The closure property. All right. So we are going to end today's lesson. We have learned a lot. We talked about the properties of operation of numbers. We talked about commutative property. We talked about associative, distributive, identity, inverse, and closure. So I know you have been able to grab the concept. If you are still doubting or you still have uh, problems getting the concept, you can go to the comment section. You can ask your question. You bring your submission and we will help you out. All right. So what I'll be doing is after this lesson, we are done with the first lesson, which is what? Row number system. So I'm going to post your assignment. Yes, your assignment is going to be posted. So you need to take the assignment and try your hands on solve it. All right. If you have any question, you can ask in the comment section. So see you next time. Thank you. Bye bye.